Hi, this is Mark Griffin, the Director of Customer Solutions here at Construx. We're a team of software engineering experts led by legendary author Steve McConnell. Here we believe every software team can be more successful at delivering high levels of business value. Every episode, we talk with one of our consultants, exploring different types of engagements that we have recently completed. We describe those engagements, the issues that we found, and what we have done to solve them. And along the way, we certainly have a little bit of fun. So let's get to this. It's not entirely clear when this podcast will be available, but I think it's fair to say that a lot of us will still be safe distancing in our little worlds when it does go out and go live. So this is the new norm. And personally, I've established the sort of the bathing schedule that works for me, the shaving schedule that works for me, even the wearing the pajamas until 3 p.m. schedule. And I am currently sequestered in Sammamish, Washington, about 15 miles east of the Construx headquarters in downtown Bellevue, Washington. I do hope all of you are safe and healthy at this time. It is an unusual situation we find ourselves in, but I think we will fight through this. Today, we're joined once again by returning Construx Senior Fellow Earl Beatty, who comes to us from a little town up north of Seattle called Maltby, Washington. As a quick, oh yeah, I remember that guy summary. At Construx, Earl has designed and implemented improved software practices for companies in industries including telecom, computer hardware and software, pharma, medical devices, oil and gas, retail, many others. His innovation and initiative was one of the driving forces behind the Construx on-demand e-learning content, and he is one of our more experienced practitioners in this new world of virtual instructor-led training. Welcome back, Earl.
Hi, Mark.
So how is life in the throbbing hub of downtown Maltby this morning?
Well, we had a lot of congestion around the bird feeder. But
yeah,
it's like a lot of places, the traffic is way down. We actually are near hearing distance of a minor highway, and it's been interesting how quiet that minor highway has been. So pretty quiet here in our little part of Washington State.
Yeah, this is pretty interesting. The bird feeder hits home with me. I spend a lot of time looking out my window watching the squirrels batter the seeds, and so I have this real-time war going on with these little furry fellows. It just bothers me. So anyway, but we're good. So today we're going to explore a familiar topic and one that can pit leadership against engineering on occasion. And that is this idea of trying to lower inherent uncertainty on large work efforts, large projects, large releases, et cetera. Steve McConnell's recent book, More Effective Agile, talks about this idea of success with agile software projects. And, I think it's been well demonstrated that small projects, regardless of the life cycle, whether it's agile or not, have a higher success rate than larger projects. It's just those large work efforts that create much more difficulty for teams to be successful with. And they've been shown to have problems almost right out of the gate. So that's what we're going to talk about today, how to lower that risk. So to continue to frame that conversation, Earl, in this recent engagement that you were on, you did a workshop and you continued to remote coach a large multinational medical organization. And with this organization and this engagement, you were there to help about pre-project planning. And I think in commercial software, the idea of a funding gate used by organizations to justify continuing with an idea is pretty prevalent, meaning that, how larger projects get funded for their entirety depends on what they do up front. So maybe we should define the broad strokes here for this particular engagement. What is this inherent uncertainty that you're servicing with this topic?
Inherent uncertainty, that's a really interesting sort of concept. A guy named W. Edwards Deming used to talk about two kinds of variation: common cause variation and special cause variation. And inherent uncertainty is really that common cause variation. Think about your commute to work. When you drive to work, if I asked you exactly how long does it take you on a particular day and you had to bet significant amount, you'd be a little nervous because there's some variability. Will you make that one light?
Not
Will
today.
there be backup in traffic? All that kind of stuff.
Right.
Right now, yeah, our commutes to work. How long will it take me to get from the bedroom down to my workstation?
Exactly.
But there's tea to be made, and depending on how hot it is, do I have to make a fresh pot? Do I want to eat before I go there? There's always variability in any process. And the longer and bigger the process, the more variability. And that process is what drives inherent uncertainty. And this is particularly true in software projects, because on software projects, we've got a lot of things we need to decide up front. And so there's lots of inherent uncertainty. Until we make those decisions, we don't know much.
And this is totally true. So what do you do early on, like when you start working with a team, and this team that you had this engagement with when you went to overseas and talked to them? What do you do early to help that team set themselves up for success? What kind of things can you talk about there?
The thing to understand about inherent uncertainty or common cause variation is that to actually reduce it, you can only do a couple different things. One thing is to change the process entirely. That's what some things Agile did. For the development team, they took a process which could be months and months and months and said, we're going to take it down to 2-week processes, right? So in 2 weeks, you can't have that much variation. That's like the commute from my bedroom down to my desktop, as opposed to the commute from my bedroom to my office in another city. So that's one thing you do. But if you're going to be living a process, the other thing you can do is actually start working the process, start executing it, which means we need to make some sort of initial investment to make those early decisions that rapidly buy down the uncertainty. So what I do in the organization, I help them start to understand what decisions do we need to make, how we can go about making them, and how that will help us drive down that initial wide part of the what we call the cone of uncertainty, or the wider inherent uncertainty, or the larger amount of inherent uncertainty that's typical of a software development project.
Right. So again, this is to the larger picture here. We're talking about the business requesting something, engineering going off and trying to come up with some thoughts on how to implement something. I mean, the business in general wants clarity from engineering about what they're going to get and when they're going to get it, and really how much is it going to cost. So what kind of things do you do to make a commitment of scope and duration more possible when you're at the beginning of a project like that? What kind of thoughts do you have for a team that's just struggling with that?
Right. So one of the things we need to do when we're working with a team like that, like I was doing with this particular client, was that we have to start saying, here is the limits of what we can possibly know at these points within that inherent uncertainty. Because what the inherent uncertainty says, we cannot know with more precision, a more precise number than what's inherent at this point. So what we like to do is say, you know what, if you're willing to make a moderate investment, now this particular project that we're working on is tens of millions of dollars. Somewhere estimates maybe even up to 25, 30, 40 million dollars. So it's a relatively large investment. So we're saying, are you willing to invest $500,000, $1 million, right? A fraction of this overall anticipated cost to say buying down that uncertainty, because we're basically in a sense starting to execute some of the project. We sort of frame this as pre-project, but in a sense it's actually still project work, deciding about what really is this project about and how we're going to move it forward.
Absolutely. And that's interesting. And so when you start talking to the team about some of this stuff, I mean, how do you get to a point? How does the team get to a point to understand that, should you continue on this path, right? I mean, part of it might be funding, right? They gave you $500,000 to go play. How do you determine whether or not you should continue once you've gone through this process?
So what I try to do, and what these organizations need to do, is that they need to say, here are the decisions we need to make in order to buy down that uncertainty. So for this example, they really need to do a couple things. They need to look at what really is who is their primary scope drivers, and what are the main things they need to deliver for those primary consumers that they want to have. Right, so setting the broad strokes of the scope very clearly and precisely, and what's not in scope. And also start looking at the broad brushes of what technologies we're going to use, and then getting a sense of that and using estimation techniques at that level. Unfortunately, what a lot of organizations do here, they start to say, you know what, let's go get a team out and let's try to plan it down to small bite-sized 1 week, 2 week sprint chunks, name all the different stories and all the sprints way out in advance, when really they have no idea what they're doing. They're just making stuff up half the time. And so the idea here is say, we need to get clarity and more definition in the sense of what the overall scope is. And then we look at techniques to size that. And then we start looking at that and saying, here's the business target. Here's what we're really seeing. How do we start adjust this so we have a reasonable chance going forward and not taking on too much risk?
Yeah, and I guess that's good. That's a good contextual understanding. It helps you visualize. I mean, I think let's unpack that a little bit further. And I think I have three main points I want to kind of go through today. And the first one is really let's talking about how the organization might set themselves up to be more successful. Right? There's lots of ways, a lot of things they can do, but what kind of things can they do that? And the inherent uncertainty. When you talk about projects and estimation and things like that, diagrammatically, that's been illustrated by this famous cone of uncertainty. And I think a lot of our listeners are probably familiar with that if they've been following Steve McConnell over the years. It was first brought to light, Steve will say, by Barry Beam, and more attributed to him, maybe to Steve McConnell's work in his book Software Estimation: Demystifying the Black Art. There's this wide end of the cone. You look at that talks about uncertainty in estimation, and then as the project progresses, it tapers down to a narrow end. Hopefully it tapers down to a narrow end. But once you go into a little bit of a primer for people on what that idea is about the cone of uncertainty.
Well, the cone of uncertainty, as you said, is a picturesque way of first illustrating Barry Beam's data, and now last week when we're recording this, Steve McConnell recorded an update to the cone of uncertainty where he shows some Construx data in a Construx cone. But what the cone shows is that our ability to precisely estimate very early is very, very poor, that there's a wide range of uncertainty. In the Construx cone, they said that we tend to underestimate somewhere in the tune of 600%, 500% very early on in the cone. Underestimate, we occasionally overestimate, maybe 100%, but the strong prevalence is to underestimate things. And this is the long-term problem that we see in software development, and that the cone really represents clearly, is that early estimates tend to be massively underestimated. And this causes all kinds of downstream problems. So one of the things we try to do, especially in this pre-planning process, this early project work, is to help them sort of say, okay, let's work with the cone rather than pretending like the cone doesn't exist, because that's what we see more frequently. Is like, let's pretend the cone doesn't exist. So let's pretend this is not very wide at the beginning and just go forward as if we know everything. And so what we're going to do is say, hey, let's see this cone. Let's see what's knowable here and what it takes us to narrow the cone as opposed to pretend the cone doesn't exist.
Right. I mean, do you think in general engineers are optimistic? Is that why there's so much underestimating that goes on?
I think there's two main problems. One is that engineers, forget it, humans in general are optimistic.
Engineers are humans occasionally.
We're right in the middle of the coronavirus uptick swing here at the recording. And, I'm still hearing people going, well, I don't think I'll get it, or my going out won't cause any problems. We're all super optimistic in the local term. So that's one big problem. And the other big problem is that we all think in terms of solutions. And so we're already 20 feet or halfway down the project pipeline thinking of all the solutions we're going to build when we haven't yet even defined the problem very quickly. That's the issue that's really at the heart of the wide end of the cone, is that the problems are very poorly defined. We have technology. We want to build this technology. We have a kind of vague sense of what problem we're trying to solve. For example, on a different client, not the current one I was working on, but a different client, thought their job was to create a whole bunch of measurement potential in their medical device, that we needed to create 50,000 ways that they can use, just in this case was the ultrasound machine, to measure something. And this was going to take 11 months.
Wow.
And they were thinking all this detail. And we said, whoa, back up a second. What problem are we trying to solve first? And the problem we were trying to solve first was, how do I take one specific kind of measurement? And so when I pressed the measurement team saying, how long would it take to build just the one specific, because here's the problem, we only want to take this one specific measurement. How long would it take to build something like that? And they said, about 3 weeks. Right? And so it's like, until you clearly articulate the problem, every solution looks equally valid. And you got to do it all, because there's no reason not to do it all.
So from that planning perspective in the beginning of the cone, the time that you spend in there should be well spent on really defining the problem. As if even if the business really knows what the problem is and is articulated to you, the engineers don't necessarily know the problem they're going to build and fix.
This is especially difficult now that we're going more distributed, right? As no longer we're sitting together. You might have been able to pull this off a decade ago when we're all sitting together and the marketing team is just 2 cubicles over and you're like struggling as a developer going, oh, I'm not really sure. Hey, guy, and get a quick answer. But right now with the developers sitting typically thousands of miles away from the product owners, you can't pull that off anymore. And so it's really even more important now to really invest well in this early part of the cone to say what clearly is a problem and break it into sub problems. Because we know that from our own life that we don't solve a big problem with a big answer. We solve a big problem by breaking it down into tiny little problems, solving little problems, then those adding back up to the big answer.
Absolutely. I mean, what are some other, I mean, call them key decisions maybe that should be made early, and what kind of things would you recommend based upon that? I mean, you talked about defining the problem, but what as you continue to explore, what other things should be made at that point in time to help the business?
So one of the things I think is very handy to build right off the bat is a context diagram. A context diagram puts what you're building in the middle of the context, the middle of this picture, and then all around it puts the things that interact with what you're building. Not with the overall product, because you may be building just a piece of the product, but what interacts with what you're building. So a couple of decisions are being made right there. First of all, who's really going to be involved in this? What is your actual solution scope? What is the boundary of what you're responsible for doing? So you need to clear that up and make that very clear. Who are all the things we want to interact with? Are they really in scope? And what is not in scope? What is we're not going to solve for? Example of this was I was working with a different medical device company. I've had a lot of medical device stuff recently for some reason. And
it's timely.
They had in their outside their scope was different markets they want to go to. And I said, do you need to go to all these right off the bat? And they're like, no, these are secondary. I said, well, let's then change the problem a little bit so we can get something workable that we can get feedback on as opposed to trying to solve everything at once. And that's the kind of thing you can do with that kind of decision early on. So you need to know who's in scope and who's not in scope. And you also need to know a little bit about what technologies you want to bring to this. Not the detail stuff, but what are the major architectural decisions like we want to do this in the cloud, we want to do this as a microservice. What kind of strategies you're going to follow, you need to make that decision very early too.
Yeah, that's really quite true. And the diagramming, I think a lot of people have an ability to kind of visualize what problems engineering is working on. Sometimes there's been some obfuscation for the business. They don't really see what's happening. They just know that this team is off doing something. And so, I mean, in terms of it's rather a us versus them kind of thing. Let's talk about it more in terms of the business and development and how they work together. What kind of things are expectations on either side of that delivery pipeline that happen that maybe in the beginning of the cone, or things that business and development can do better to make that communication flow easier? Are there things that you have experienced, and maybe even at the same time you give some counterexamples that were just the wrong things to do as a way to illustrate how that working relationship should happen?
I like to get the business development working together on the same deliverables. So instead of having a document that's business oriented and a document that's technology ordered, try to build one document together. Because the real issue here is development. Unfortunately, it's turned out to be development's responsibility to help the business think about the business. Too many of our business people are now very technical savvy, as almost as much as some developers, even some are former developers. And as such, they're coming in and they're doing high-level design and medium-level design, and sometimes even case low-level design. And this is where it goes off the rails really quickly, because everyone's doing design and no one's going back and talking about the problem. So it's becoming development's sort of mantra and responsibility to say, well, that's an excellent idea of what we could build. Tell me how that's going to help you sell more, or tell me how that's going to help this consumer get their job done. What is they're struggling with that you think this is a great idea to help with? So part of this working together is to help the business go back from its natural tendency of every human, which is to talk about solutions, things that are concrete and real, and start talking about this more nebulous world about why the heck are we building this? So we can make little decisions when we do build it that actually support solving that problem as opposed to just delivering working software.
Right. I mean, it's a comfort zone, I suppose, to some extent, right? I mean, people who maybe were prior to moving into the business side were developers, and so they kind of continue to wear that hat. And engineering is really trying, or development in this case, is trying to tell them there's enough that you have on your plate for the business side. let us handle
but I also think
right.
it's just a difference between abstract thinking and concrete thinking.
Right.
What you build is very concrete. You can look at it, you can point to it, you can say that does this. Whereas describing a problem, I mean, it's very difficult to say, wow, why am I doing that? Because I think deep inside of us, we have no idea why we do many of the things we do. I remember a great sort of illustration of this years ago is a guy was talking about how do people think of things. And someone says, why'd you do that? And what we do is that we go into our head and we have like an old Rolodex file. Maybe it's like a database search now and go, oh, I just did that. What are the best reasons? And we flip through our little Rolodex or our database search, looking at different answers, going, this answer, we find one and go, this answer looks really, really good. And so I'm going to use that. That's why I did it, is what we say. Whereas you go to a child and you say to a child who just did something, you say, why'd you do that? They look up at their database or their Rolodex or their database, and there's nothing there. And they go, I don't know.
That's a good analogy. It's actually really, really well said. So this is actually a good bridge into the second point we want to talk about today, and that's this idea of actually recording the early decisions. And this is not just some kind of CYA thing, right? There's a reason why you want to do this. Why don't you talk a little bit about that?
Right. So one of the issues here, I mentioned it before, is that often the business gets a document. We'll call it a user requirements document or a product requirements document. They get this document that it's theirs to fill out. It says, this is where we're going to record the things that we want to record. And the technology people, they get a document. The tech people get a document called technical requirements document or high-level design or medium-level design. They get a document where they record their stuff. But what they're not looking at here is what's being recorded in those documents. Now, if this was to be done really well, the business people should be recording business type decisions. And those decisions are things like who is the customer, what problems are they having, what workflows do we want to support, how we make those workflows better so they actually want to give us money or something like that for our product because we've made their life better. And the technical people should be making decisions like, oh, here are the features we want to build that will help drive that acceptance of because it solves those problems better than how they currently solve them. Here's the architectures we want. Here's the technology we want to use. And we should actually separate those out by levels of decision scope. And this is going back to that cone idea. Different decisions have different scopes of impact. If I make a decision saying we're going to do microservices, that has a huge impact. That's a wide impact over what we're building. If I decide we're going to use this particular sort algorithm, that has a very narrow impact. And so this impact of the decision, whether it's a wide impact or a narrow impact, depends on what sort of level it belongs in. So we got these two areas. We got what are the business decisions? And I like to think these as columns. We got a business column and a solution column. And then we have levels about the scope of the impact of the decisions. Unfortunately, what happens when I have the business people having their document, they make both business decisions, but more often technical decisions for the reasons we've already discussed. So they're making things on the technical column, and they're making them on all levels. You go through one of those product requirements documents, and there's just like a shotgun, a splattering of decisions of all different scopes, right? That are over the entire product versus one little tiny thing. And they're all stuck in this one document. And no one knows how to make heads or tails of it and how to deal with it properly. So one of the things we try to get people to do is start saying, hey, let's be more intentional. And this is what we happened in this one client that we started this conversation with. They're really starting to see and how we can start putting things into documents based upon what are we deciding about and what's the scope of the decision that we're trying to implement with that decision, and have different levels of documents for different scopes.
So, I mean, what are some of the ways that teams capture these things? Are they in like is there an online repository? Is there what's the sharing mechanism for detailing this information?
Right. So that's a really good question, because this is a little bit of a struggle, because a lot of them are using Azure or Jira or Azure DevOps or Jira, and those tools are inherently poor at this. They're not very good at this. I mean, they're good at some little parts of it, but what I'm trying to encourage them to do is to say, hey, let's separate out what I call a working document from a repository. The working document is going to be the things in Jira, things in Azure DevOps, little story notes, PBIs, at different levels of decisions. What we're going to do is say at the end of every increment of work, whether you're doing agile increments or milestone delivery of some kind, what I want you to do is at the end of that work, when you say you're done with something, part of your definition done is to say, now that we've built it and we've seen what we have, let's update the repository document. So design, instead of having a to-be design, we're going to have a bunch of notes and whiteboards and stuff like that, working spaces, and then we're going to build it and say, okay, let's document the design that we actually built. Requirements, we're going to have stories and PBIs, and then when we're done, let's update the requirements document to what we actually built. So as we go through, we're going to use Confluence, SharePoint, probably those kinds of things. But we're going to have a living document, a living repository that we're going to have all these working documents feed into. And then for the working documents, yeah, you can toss them.
Okay. Yeah, and I think that makes a lot of sense. You're sort of, wasn't there, I think there was something called as built, right, where you look back and say, okay, this is the things that we did. We had an intention going in, but this is what we captured on the way out of that. So recording those decisions. You make a distinction. I think we were talking about this before. There's this decision scope strategy that we've been talking about, and there's something else called a sort of they-tech strategy, right? What is the difference between those two approaches?
Right. Yeah, this is something I like to talk about quite a lot. The they-tech strategy is sort of they get their document and technology gets their document. Since I'm normally talking technologists, the they is the business, the marketing, the users. They get their document, tech gets their document. And that leads to that splattering of decision making, because when they have their stuff, they put whatever decision they want to make in there. Either decisions about what problems to solve or decisions how we're going to solve it. It's all in there. And then tech gets that and they're supposed to think, oh, I need to decompose from that. But it's at all sorts of different levels and all different levels and all over the place in terms of problem solution. They don't know what to do with it. But this is the common way of doing it. It makes sense from a 10,000-foot level, the they tech. If they stuck to a certain level of decision and certain column of decision, it would be fine. But no one ever does that. Whereas the decision scope says, hey, we need to make an overall product decision. What are our product decisions, both in the business side and the technology side? And I like to put those together in one document. And I like to put them together in one document so I can see that they balance each other out. If we're making a technology decision like, hey, we want to go with microservices, we have to go back to the problem and say, what problem is that solving over here? I was actually working with a large coffee company that I won't name. And one of the things I was talking to them and they said, yeah, we're going to go up and do web microservices. It's the thing du jour. And I said, oh, interesting. I said, why are you doing that? And he says, well, we just want to do web microservices. I said, is that helping solve some problem? No, we just want to do web microservices. And it's like, really? That's not a good reason. You're taking on more risk, more complexity, you're delaying the project, and you're not actually solving any problem over here. Right? And so by putting them together in the same document, that's why I call the decision scope document. By putting together, I can make sure that they're balancing each other out, and both of them have to agree. Yes, we agree. This is how we want to proceed forward. They both sign off on that same document, as opposed to business says we put whatever we want in ours, and tech says we put whatever we want in ours, and hopefully they match someday.
Yeah, that's a disaster. So, I mean, you mentioned Azure DevOps and Jira. They're not very good at documenting, the decision scope method you like. What kind of documents or recording hierarchy do you recommend, or what have you seen as more common in the better teams that practice this kind of stuff? Is it just simply Word or Excel documents, or is there more sophistication than that?
I like to encourage more sophistication than that. I mean, there's nothing wrong with Word or Excel documents, but they leave too much out. I've been really encouraging narrated storyboards right now.
Okay.
This is where we use PowerPoint, and you can use a nice slide deck, or you can just draw things out there, but actually having the human voice narrate pictures about what's going on. If you can go out, for example, on a product scope document. A product scope document is a great one at the product sort of level. What are the decisions that we want to make both on the problem and the solution about what the product scope is? So I want to go out and have pictures of the environment it's going to work in, pictures of the people who are going to use it, pictures of the other machines that are going to use it. So that not only do we have text around this, we have images and narration and motion and video. Take advantage of all this technology we have and all this huge cloud space we have to store things and stream that video back. Right now, we use Microsoft Teams for a lot of things here at Construx. And we got Microsoft Stream. We can put long videos up there about how things work, and people can watch them. And we can put chapter markers on this so they can jump to important concepts. So there's a lot more than just the Word document or the Google Doc, but actually using the human voice a lot more in those things, because you can record narration like we're doing here in our conversation, and include images and short videos about how things actually work.
I think that makes a lot of sense, and then certainly in the environment we find ourselves in, or even in general with organizations that are severely distributed. Having that voice overlay, having somebody point to things, having people explain things in deeper detail, and you archive that off, that you can go back and revisit that and say, the intention we did at the beginning was to do the following, and if we're going to revisit that, we certainly can revisit it, but at this point in time, this is where the decision we chose to run with, right? I mean, I think that makes complete sense. I mean, that kind of brings us to the third and final topic today, and that's this idea. I mean, you do all this work, right? And you're eventually going to be putting things into some kind of a product backlog once the team decides to go forth, right? So this notion of priming the product backlog, what do you mean by that? Maybe you can kind of we can spill into that topic.
So one of the things, and we're going back to this idea of early count of uncertainty, is that we need to make some decisions about what the overall scope is. But we also can't really estimate well unless we have some idea of what that, not only the scope is, but some idea of how we generally think we're going to solve it, right? Or overall technical strategies and stuff like that. So what priming the backlog means is, how can we do enough work to get enough content in the backlog, whether it's a brand new backlog or it's hey, we got to revisit this backlog to make sure that it's in the right proper order. So what I have teams do is I start saying, okay, let's identify the top 4 or 5 main consumers. And again, we can go back to that context diagram and start saying, who are our main consumers here? And then we look at the consumers and start saying, how are they interacting with what you're building? That becomes our first use cases. For the ultrasound machine, it's to one of their first use cases, overall use cases, was to identify the location of an anesthetic needle for anesthesiologists. That's what they want. I need to know where this needle is, right? And then we can start looking at all the different ways they could use the tool to find out where the heck that needle is, and all the variations on that and what they could do with that information once they found it. Sometimes they archived it, sometimes they didn't. So archive was one particular pathway through that, and without archiving is another pathway through that, right? So those are the different kinds of pathways they do. But by having that major use case and then breaking down by these pathways, now we've got a whole plethora of potential stories or epics that we can put into that backlog. Once we get those epics and all those stories in there, the technologists can go saying, hey, roughly, given our knowledge of technology and our strategies we've made at the product scoping level, that we want to do microservices or we want to use this kind of technology or that kind of technology, let's put t-shirt sizes on that. Let's start sizing those in t-shirt sizes. And then we can, once we get those in t-shirt sizes, we can start doing trade-offs. We can start saying, hey, this one is a lot of value, but a small size, we should probably do that early on. And that's priming the pump. And this one has a lot of very little value, but it's a huge amount of money. You marked it as extra large in cost. Let's delay doing that because it's not delivering nearly as much value. We can get a rough order. So we got a clarity around the backlog now that allows the team to actually start doing work instead of fighting about what should be first and what should be second.
That makes a lot of sense. I mean, even to the extent, even at a higher level, saying even are some of the targets set up by the business even feasible, right? You in this decomposition process, you get enough context to say, you know, that approach might not even work, right? You can do that.
Right. If someone says, why is this, if this team sizes as, say, extra large, they'll say, well, maybe one question goes, why is it extra large? They say, well, there's a lot of risk on this one. This one has a huge technology risk. Well, what can you do to buy down that risk? Well, you give us 2 weeks, we could do this research and we could find out whether that technology is even feasible or not, in which case we might be able to size it down to a medium or a small. But right now, because we don't know, we have to size it extra large.
Sure. I mean, you're sort of giving in real time, you're giving some incremental options to leadership, right? And again, as you think about this thing in terms of maybe the project being gated, right? As you continue to get clarity on the work presented to create a business solution, then you know, you can maybe come back after doing some exploratory and say, you know, here's some ways to think about how we might want to approach this. And, you know, the business team might agree with it, or maybe they come back again in an incremental fashion and ask you to redefine things, or maybe you give them the information that they needed and say, you know what, we're just going to walk away from this. This is not something that's going to make sense to us. What is there a danger of getting too granular? Getting, you know, too lost in the weeds of this approach?
Everyone is already arguing about these little tiny decisions all over the place. It's like we don't even know clearly what problem you're working on yet. It's amazing the number of times I've gone into a development team and they're trying to plan, and I ask them, what is your product? And they don't know. I mean, they have a general idea of what this is, but I say, no, exactly what is your product? And they're like, it's a thingamabobby.
Are you saying more like
they don't even know their boundaries very well? And so,
Sure.
so it's like, why are you planning all this detail out when you're not even sure what the boundaries are?
I mean, you get answers back like, you know, a GUI engineer says, well, my widget does the following. Or are you talking about just more in general, like they don't even understand the holistic view of what they're trying to do? They're just more compartmentalized already.
And this is huge, because what I see more and more, and perhaps you've seen this too, Mark, when you've talked to clients, is that developers, for the most part, and this is a broad brush, so I'm happy there's potentially lots of this wrong, but developers for the most part are still coding shops, right? They're not solution centers, they're coding shops. Someone else is saying, build me one of these things. And they're going, okay, I'll build you one of these things. And then they build it, and then the person getting going, well, this isn't quite what I wanted. Now build me one of these things. And they go back and forth.
Sure. Yeah, go ahead.
Oh yeah, it's going to say, and this is taking projects a very long time. And then down in the technical side, because they don't want problem, people start arguing about whether path A or path B, which both sort of sound will build what the guy kind of wants, which one's better. They can't make that decision, so they keep sending emails back and forth. And this is just exacerbated by our distributed workforces.
Sure. I mean, this process, I mean, I think about this, the uncertainty aspect of this, right? You're trying to bring clarity to implementation, you know, and there are a certain amount of detail I think are necessary for people to understand what's possible for them. But I mean, how far down that rabbit hole is advisable for people to go? I mean, you know, you want to have this sort of a description, or I think you're using the word use cases that fall out of some of the top few consumers of the solution, right? I mean, how deep do you really need to go in order to provide sufficient, even funding information for somebody? I mean, you're certainly going to be doing estimation of how long it's going to take for you to fully flesh out these solutions. But, you know, how at this wide end of the cone, how much of this stuff is really needed? How deep do you need to go? I guess. And that's probably like how long is a piece of string, but I'll throw it out there anyway.
Yeah. Yeah. So you brought up a concept earlier, which I think is relatively important, especially in these larger work efforts, is that the idea of gating. I think
Mhm.
one of the things that I think Agile struggled with early on is that Agile really treats everything like a very small project. Because for the development team, it's really just a series of 2-week projects. That's all their world really is. But for the project leadership team, it really still is a large work effort that's going to take months or even potentially, like this client we've talked about, years to build. And so the gating becomes really important. And those first gates are really the business's opportunity to say, we had this idea in our head that sounded really, really good. Is it really going to work? And so when you walk up to those early gates and we're driving down that early kind of uncertainty, yes, we have to have the scope fleshed out. Yes, we have the technology fleshed out. But here's where we can take advantage of some of our agile concepts too. Because what I want to walk into that gate with is not just here's what we think the scope is, here's our technology, here's some documents, but we've actually built a few small threads of working software or working product, even if we can pull it off, right? That, yeah, it only does a small fraction of what we want the overall product to do, but we've actually engaged each level of our architecture that we've outlined here in this big architecture document. And here, how is it solved one small aspect of the problem? For example, when I was talking about that ultrasound, right? They were going to build that first little one, which is, the whole project was supposed to take, well, when we first got engaged with them, you remember this one, Mark, you were on it too. They were in their 4th year of a 1-year project.
Yeah.
And they had nothing, they didn't know what worked on this yet. And so we turned them around and said, hey, within a month or two, we actually got this one thread working that exercised the entire thing. Then we added another thread. And so they were able to walk into their funding meetings because the funding obviously was starting to dry up. They're going, 4 years, nothing here, folks? Really? Right? But now they were going into the funding meetings and say, here is actually working product. And here's how we plan to keep adding to it. And that's a much easier decision, I think, for the business to make than to say, well, yeah, you do have some signed off documents and they do look very signed off. So let's go ahead and give you another $10 million, right? That's nonsense. As opposed to, oh, you have a strategy and we see how you've actually executed that strategy on some relatively important bits. And you actually have a reasonable plan because you actually have data for how you built those things and that you've used that to help us understand how the rest of it can be built out in real time. That's much more powerful to a gate to me, to the people who are trying to make that go, no go decision than you have a bunch of signed off documents.
Sure. I mean, in the case of an agile team, we use this. We always talk about this notion of vertical slicing, right? And so you're talking about even in the early cone work, having some ability to demonstrate something all the way through helps the business kind of get their mind around the fact that yes, this makes sense to continue to fund, and let's go ahead with the project. Does that make sense?
Yeah, I think there's nothing more exciting to fund than saying it's actually starting being built already.
Yeah.
And that's one of the things I think was really the nail in the coffin for sequential waterfall development. Though you can do really good waterfall development, it's just really hard to convince funders anymore without seeing something. Right? You want to see something being built. And so Agile's idea of, hey, we're not going to build a lot of these early funding points, but we're going to build enough to show you that we got a good strategy, that there's working software, we're starting to get feedback. I think that gives a level of confidence and warm feeling that people can say, yeah, I'm willing to give you another chunk of funding.
Yeah, I think that's completely. I mean, I think in both sides of the potential fence here can understand the value to doing that. The engineers, I think, understand that hey, we're going to get you something that we feel visualizes what we are going to be doing, and the team is able to grok it much more easily. Any parting wisdom here on this whole subject for today, Earl? Anything you want to say in summary?
I think there's a couple things I want to say. One is that doing this well is still a little bit uncharted. Back in the day when we had large 3-ring binders, oh my man, I am dating myself. 3-ring binders, 3-ring binders with methodology in them. We had a little place to put everything, but with the agile revolution of the early noughts, of the naughties, what we saw there was the tossing out of all that, knowing where things went, because we just built stuff. Working software was its own documentation. Well, we've discovered that's not true. And so we're still now reinventing, where do we put stuff? So where do we want to put technical decisions? We still have to invent that. So my parting wisdom here is to really think about this idea of a, if you will, sort of a matrix where the columns are problem and solution, and the rows are scopes of decision, product level scope, feature level scope, step level scope. Because if you start thinking that, you start saying, oh, here's a decision we made. Where does it belong? And if you see you're making all these technical decisions, regardless of who's actually making them, don't worry about who's making them. Just saying, oh, here's a technical decision. It belongs at this level of scope. Do I have corresponding decisions that match that in the other column? And that can give you a really good sense about going forward with this.
That's really good. That's really helpful. I think that's helped a lot of people here today. You know, this has been great. I'm getting a virtual sign that we're going to have to call this a wrap from my producer. Thanks again, Earl, really, for taking time out of your day, from watching the bird feeder and whatnot to talking us through a pretty challenging subject that plays out all the time in software and systems development arenas around the world. You are a calming voice, and we really appreciate you being with us today.
I'm happy to be here, Mark.
So be sure to tune in again for another episode of Inspect and Adapt, the Construx podcast. Until then, this has been Mark Griffin as your host. Liz Ostaszewski will be our post-recording audio engineer, and Devin Musgrave has been our virtual producer. Be safe, stay healthy, and have a great next sprint.
If you enjoyed this episode and you have comments or would like to talk with one of our practitioners, reach out via email using comments@construx.com. Again, that's comments@construx.com. We'd love to hear from you.